We shall take a look at hydrocarbons first. What do we mean by the term hydrocarbons? Like its name sounds, hydrocarbons, they are simply compounds that contains carbon and hydrogen only. And these compounds can be saturated or unsaturated compounds. Saturated compounds are compounds that are having single bonds between the carbon atoms, as we can see displayed. And a good example of the saturated compound displayed is propane. It is called propane. It is a 3-carbon compound. It is called propane. We should get to understand why that is so. The unsaturated compounds could have double bonds or triple bonds between its carbon atoms, and that is as we can see displayed on the board. So these are examples of what we refer to as hydrocarbons, compounds of carbon and hydrogen only. Now, away from hydrocarbons, let us look at the next kind of classification of organic compounds called heterocyclic compounds. What do we mean by the term heterocyclic compounds? Heterocyclic compounds are usually aromatic compounds in which one of the carbon atoms have been knocked off, or we can rather say have been replaced by another atom, which could be sulfur, oxygen, or nitrogen. These are compounds we refer to as heterocyclic compounds. So in a ringed kind of structured organic compound where one of its carbon atoms have been knocked off, or you can use the word being replaced by another element, such compound is said to be a heterocyclic. It is no longer a homocyclic, but a heterocyclic compound. Examples include thiophene, furan, pyrimidine, pyrrole, and tetrahydrofuran. Looking at the compounds displayed, we can see that sulfur has replaced carbon in its place. Similarly, oxygen also, where it is seen, actually replaced the carbon that was there before. And nitrogen in pyrimidine, 2 nitrogen atoms replaced 2 carbon atoms at different points in that pyrimidine structure. Similarly, in pyrrole, the amine group NH replaced the carbon atom that was initially there. Okay, so these are examples of what we refer to as heterocyclic compounds. Now, having seen that, we shall now look at aromatic compounds next. Like we said, we are going to be taking a look at the meaning of those terms one after the other. When we talk about aromatic compounds, they are simply cyclic or ring-shaped compounds, which are benzene compounds or derivatives of benzene. When we talk about benzene, benzene has a unique structure. For some of us, this may be the first time you're hearing the word benzene. Don't worry, you will get to understand and know what the compound benzene is and how its structure looks like. So, aromatic compounds are simply cyclic or ring-shaped compounds, ring-shaped compounds that are benzene compounds, or you can say derivatives of this benzene compound. Organic compounds that are not aromatic are classified as aliphatic. That is to say, they are not ring-shaped. Aliphatic are not ring-shaped. They are open-chain compounds, not ring-shaped like benzene. That does not mean we may not have a kind of circular aliphatic compounds. Yes, there may be circular kind of aliphatic compound, but they are not ring-shaped. But their cyclic shape is not having strong stability like that of aromatic benzene compounds. So, aliphatic compounds may be cyclic, but only aromatic ring compounds have special stability in their structure. And examples of aromatic compounds, as we can see displayed for us, is benzene, toluene, pyrimidine, phenol, naphthalene, etc. In the case of naphthalene, you can see it is a double benzene structure. Phenol has the OH, the hydroxyl or hydroxide group attached to the benzene ring. Pyrimidine has the nitrogen atom replacing one carbon atom that was initially there. So it is also an example of a heterocyclic compound. It is a heterocyclic and an aromatic compound. Toluene having CH3, methyl. We are going to know why it is called methyl. CH3 in organic chemistry is referred to as methyl group. We're going to see why it is called methyl as we proceed in our lesson today. So having seen the aromatic compounds now, we shall take a look at our next kind of compounds, which are called saturated and unsaturated compounds. Like we said before, saturated compounds are simply compounds that are having single bonds between each carbon atoms. That is to say, as each carbon atoms catenate, they catenate with just single bonding. And examples of these saturated compounds as displayed on the board: propane, 2,2,4-trimethylpentane, hexadecanoic acid, which is a fatty acid, and we have octanol. Octanol is an example of an alcohol. So these are examples of saturated hydrocarbons, so saturated organic compounds. Away from saturated, let us look at the unsaturated compounds. Like we have said, unsaturated compounds are compounds that have at least one double or triple bonds. That is to say, they must have a double bond or a triple bond. At least one double bond or a triple bond between each carbon atoms. Sometimes they may even have a combination of both bonds in the carbon structure. So, good examples of unsaturated compounds are, as we can see, butyene, also called 2-butyne, butyene or 2-butyne. We have ethyne or acetylene. We have 2-methylpentene, 2-methylpentene. We also have hept-135-triene, hept-135-triene. Lastly, we have ethene or ethylene. These are all examples of unsaturated compounds. Why? Because they have at least a double bond or a triple bond between one or two of each carbon atoms. And these carbon atoms, sometimes we have said, may even have double and triple bonds in the structure. But so long there is at least one double bond or more, or one triple bond or more in the structure, it is referred to as an unsaturated compound.